Okay, so now we're going to prove 3.7 lemma for a linear system and for any particular solution. This vector p, the solution set equals p plus a homogeneous solution, or such that h, this vector, satisfies the associated homogeneous system. Now, we need to understand what's happening here. So we need to see the two sets, okay? The one thing is the solution set, okay? And that's this part. And it equals this set here. So we need to show that the solution set is the same set as this one. And when you're trying to show two sets equal, right, you need to take any member of one set, right, any member of the solution set, and show that it's in the other set, in this set, okay, or whatever. You could call this set A and then this set B. So what do you want to do? You want to show that any member of A is in B, and then you want to show that any member of B is inside A, and then we say that the two sets are indeed equal. So what's the way to do this? You say, okay, let there be some solution. Let the vector S be a solution to the system. Right? Now, what I want to show is I'm taking a member of the first set A that I called it A. I said, okay, now let this be some element inside of A, because S is a solution, right? So then that means that S is in this set. I need to show that it's in this set, that S can be written as a particular plus a homogeneous. So the way we do this is we say let right. Okay. If S is a solution to the system and P is a solution to the system, then we should see that S minus P is a solution to the homogeneous system. And we should maybe prove that, right? Well, why is that true, right? So if the original system is something like, if a row in the original system, is x, 1 ... a ai1 ain x sub n, right, equals di, right, then that means that the ith row in the S vector and the ith row in the pth vector make this equation true. So that means both of these following things are true. That if I plug in right here, I get a I s sub okay, wait, so it's actually all of them. I shouldn't say that, this is S1 through Sn, so you're going to be plugging in S1 through Sn here. And this will equal d sub I, but simultaneously, right, if I have, that P is a particular solution, then P1 through Pn is also equal to d sub I. So now, why is it that the S vector minus the P vector is a solution to the homogeneous system? Well, that makes sense, because if I say, that X, the associated homogeneous row would look like this, right? Equals 0, right? Okay, now let's see. So what does this vector look like? Well, it's just S1 minus P1, S2 minus P2, so forth. So it looks like this, right? S1 minus P1 plus ... Sn minus Pn. And now, does this equal 0 is the question, right? You don't know, right? Well, distribute this here, right? And, if you distribute it right, you're going to go down to first just S sub n minus, right? This whole thing, let's just minus the whole part for P, right? Plus dot 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 A-I-N P-N. And then you should see that this part is equal to di minus this part is equal to di, and di minus di must be 0. And now you showed that this here is a solution to the homogeneous system. And then you should see that you could call this h. Oh, not plus, minus. You could call this h. I don't know why I put P1. You could call this h. And then you should see that it's clear that S is equal to the particular plus this h that we just found. And you see, if I add P over here, I get S. So S is indeed equal to a particular solution plus a homogeneous solution. This is the homogeneous solution here. Now you got to show the other way, right? I took something from A and I showed that it's actually in this set, right? Because it's true that if I have something in this set, then I could write it like this, always, where, this is a particular plus a homogeneous. And I showed that homogeneous is this right here. Now I got to show the other way around. Now the other way around is to say that if we have a member of B, right? So let's let S plus the homogeneous be, or what is it? P. Oh, sorry, P. Let P plus H be in, this set B, whatever, in B. Okay, here's B. Okay, we need to show that this is indeed a solution to the system. Why? Well, it's obvious, because again, if we write any ith row, right? Take this as your ith row, and we substitute this in for the solution, right? We know that P is a particular solution. We're gonna get A, I, comma 1, and then I'm gonna write P1 plus H1 plus, dot dot dot, A, I, comma N, P, N plus H sub N is equal to, and it needs to equal D sub I. Now, why does it? Because if you distribute, you get A1 plus P1 plus dot 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 going down after I distribute the whole thing over there, and I combine and I regroup the P's, plus A1 I H1 plus dot 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 A1 I sub N H sub N. But you should see that this is a solution to the ith row in the homogeneous system. Oh, wait, I did too much there. This right here, okay, is a solution to the ith row of the homogeneous system. So this is 0, right? Because this was, in this case, this isn't indeed a homogeneous solution. So then this is 0, and then this is a particular solution to the ith row. So this equals di. And then that this will equal di, because di plus 0 is just di. And now you've shown it in both directions. So indeed, you proved your lemma.